Hello everybody, my name is Michael Labib. I'm a data architect at AWS. Super excited to be here today talking to you guys about Amazon ElastiCache. So today, essentially the goal is we're going to kind of dive into what Amazon ElastiCache is. We're going to go over some of the engine enhancements, some of the things that we've sort of built into the engine based on customer feedback and things that we've identified to make the engine a little bit more reliable. And then we're also going to dive into usage patterns, so common usage patterns that we see our customers using Amazon ElastiCache with, and then we'll talk a little bit about the AWS ecosystem and how that all sort of fits together. Now, over the years, we're seeing like this massive growth of popularity for Redis, right? And a lot of that is essentially fueled by the need for in-memory databases and IoT and streaming data. But there's this other thing that I sort of kind of think that appeals to developers, right? It's this idea that Redis sort of fits into this craft of programming, right? So what is that? So essentially you have a problem, you reduce that problem into smaller problems, you develop a set of instructions, algorithms, you utilize functions and data structures, and you sort of kind of solve that problem through that mindset, right? That craft of programming. So Redis, having native data structures sort of fits into that same kind of mindset. And it, it's very appealing when you talk to developers. The developers I talk to love Redis, right? So how much more powerful is that if you can remove all the administrative aspects to Redis, right? Just give me what I need to build my applications. I want to utilize this engine. I want to take advantage of all the features and sort of, solve the problems I need without having to worry about all this undifferentiated heavy lifting, right? So Amazon ElastiCache is an in-memory data service, right, that supports two engines. We have Redis and Memcached. What it essentially provides you is zero administration for your Redis clusters, right? So all you really have to do is worry about putting data into the cluster. You also have to size it. We give you options to add parameters in terms of how exactly you want your cluster to behave. But outside of that, that's essentially all you have to do, right? So you get to focus on your business. The other thing that we've done with ElastiCache, as I mentioned earlier, is we baked in a lot of enhancements and things that you sort of learn running Redis at massive scale that we do at Amazon. The other things that we're going to be talking about today is, we'll talk about a few additional things. I'm not going to have time to kind of dive into all our features, but we'll sort of touch on a few of these. So the first one is, how do you deploy and monitor your Redis cluster, right? Just like other AWS services, we provide our customers a variety of different ways to create your clusters. The first one is using CloudFormation. So CloudFormation is essentially a template engine that allows you to write JSON or YAML scripts that describe not only your Redis clusters, right? Your engine, how many shards you want, how many master slaves, we call them primary replicas, but also all the other resources sort of tied into your solution. Now, why is this powerful, right? It's essentially infrastructure as code. So you can versionize this entire stack. You can execute it and run it whenever you want. And if you wanted to build, say, a test environment, or you wanted just to spin up the same exact identical infrastructure in another region, all you have to do is just run the script. The other powerful thing is that you can versionize this, right? So you can essentially just commit this JSON file into your repository and just have historical updates in terms of the changes in your infrastructure. The second one is command line interface and SDKs, right? So our command line interface essentially provides all the operations associated to building your cluster, right? You can also describe your cluster, create your cluster, and do things like take snapshots, backups, all that sort of thing, right? It's very rich in terms of the operations. Same is true for the SDK as well. So if you enjoy kind of building your own interface on top of this sort of administrative aspects, you can do that too. You can use a variety of different languages that we provide you with the SDK. Now, if you don't like a lot of excitement in your life, you also have the console, right? So the console is essentially, you log into it, you click a couple things, and you have a cluster running in AWS, right? Now, in terms of monitoring, we have a variety of different services that sort of augment and provide rich features for your Redis cluster. The first one is AWS CloudTrail, right? So what CloudTrail provides you is essentially an audit log of every interaction with every AWS service, or almost every AWS service. Now, why is this powerful? Say, for example, you want to be aware of, who created a cluster, who was that user, what time did that event occur. You have that sort of log within CloudTrail. And then once you have that log, you can ingest that in other services and sort of create compliance and auditing that a lot of our enterprise companies, require. The other one is AWS Config. So what AWS Config provides you is we allow you to create rules that can be triggered by Lambda functions. So AWS Lambda, if you're not familiar, is serverless compute. So essentially, you put a function in the cloud, we manage the scaling of that function, and it'll just execute for you automatically based on a trigger. Now, what you could do with AWS Config is you can say, for every type of interaction, say, a cluster got spun up or some other service interaction occurred, you can have a rule that basically checks to make sure that this complies with what you want your infrastructure to look like, right? Now, the last one is Amazon CloudWatch. So Amazon CloudWatch is essentially our service that allows you to see all your resource monitoring. Now, all the sort of Redis info and cluster info metrics get funneled through CloudWatch, as well as other metrics related to your host. Now, the cool thing about this is unlike looking at or tailing a log file and being reactive to events that occur, what you could do is be very proactive with CloudWatch. So you can set thresholds in terms of things that you want to be aware of, and then be alerted when that threshold gets crossed, right? So that's what an alarm is. Now, to kind of give you an idea here, so say, for example, you're concerned with when an eviction occurs. What you can do is create a threshold that says, anytime an eviction is greater than 1, send me an SNS notification, or send me an email, right? And there's other options that you can also trigger events on. We also give you the ability to write code within Lambda, right? So some other people have maybe a proprietary kind of notification system that they've deployed. So you can integrate that system and have your Lambda function trigger off of that SNS notification, and then pass that information to this other paging system, PagerDuty or whatever you might be using. The other interesting thing is based on specific events that occur, there might be other actions that you might want to take, right? So there's other business logic that you can bake into that AWS Lambda function. So this really kind of gives you an edge in terms of being proactive and really understanding the metrics and the health of your cluster. Now, I talked earlier about, we've added a lot of enhancements. I'm only going to cover a few of these enhancements. And a lot of these enhancements really revolve around adding features that a lot of our customers have requested that really kind of are around the reliability and durability of the service. So the first one is this, swap optimization. So what does that actually mean? So with Redis, if you are doing something like a backup, right? And assuming you have a lot of writes occurring on your master, it is possible that your memory footprint may double, right? Now, what happens if you don't have enough memory for that operation? What happens is you may fall into swap. And if you fall into swap, that's never a good thing for an in-memory system, right? So bad things can happen, including node failures. So what we've done here is we essentially detect whether or not you can perform that fork-based operation. And if you can't, we have a sort of a background job, a timer task-based job that does this backup or the snapshot in a non-fork-based process, right? So the theme here is, we're allowing you to utilize more memory. We're also preventing your node from failing due to overutilized memory. The second one is dynamic write throttling. So what could occur with Redis is if your master is accumulating a heavy amount of writes, it's possible that your slave may not be able to synchronize those operations in time, right? So there might be an added lag between your slave and your primary. So what we've included here, if we detect that problem, we sort of throttle some of your writes to make sure that the consistency and the reliability of your cluster is still there. The last one here is a smoother failover. So imagine you have a master with two slaves, right? Again, we call it primary and replicas. So you have a primary, two replicas, and then one of your primary fails. Now, we're going to do the election for one of your replicas to be the new primary. But with Redis, the way Redis works is that other replica, now the data is going to be entirely flushed because it's not able to do a partial sync. And essentially, it adds time to this failover process. So what we've done is we've made modifications to the engine where if that other slave is available, we don't flush the data. We just make sure that it's consistent with the new elected primary. And overall, this speeds up your whole failover process. So again, this kind of speaks to making sure that the reliability and the performance of your cluster is there, right? Now, while we have added a lot of these enhancements, going back to 2.8, we've been contributing back, right? So we have some of our developers who are here today. Kevin is here, Q is here as well. Feel free to chat with them after the talk or stop by our booth. But a lot of the contributions that we've done are things that we've noticed running Redis on massive scale, right? Again, speaking to the having additional reliability and durability to the service. And a lot of these contributions are in the form of bug fixes and recommendations in terms of how things would improve the engine. One thing I like to talk about is the cost effectiveness of ElastiCache. So we provide you a variety of options to consume ElastiCache. The first one is free, right? And so we do this because there's a lot of organizations who maybe in a dev environment want to create POCs or they want to teach their programmers on how to use the cluster. So essentially you get this free for an entire year, right, on a micro node. Now, the other thing is we provide you on demand, right? So there's no contracts, there's nothing involved here. All you do is you pay an hourly fee, a low hourly fee. And anytime you want to just stop using it, just stop using it, right? Now, if you have a production workload where you're already using Redis and it makes sense, we also provide you a feature where you can pay in advance, and this will reduce your overall cost by up to 65%. Of the on-demand cost, right? And that's paying up front for 1 or 3 years. And that is what we call reserved instances. Now, there's always still this temptation, running Redis on your own. And that's great if that's something that your organization wants to do. But there's one thing to be aware of that in terms of TCO. In addition to the cost that you would pay for the instances, the EC2 instances, when you run Redis on your own, there's a communication charge when you cross AZs, that data out charge. So that's one thing to be mindful of when you evaluate your TCO is you have your total cost of ownership is the cost for your EC2 instances plus the data out charge. Now with ElastiCache, we don't charge you for that data out charge. So when you factor that in, a lot of times what we see is that self-running Redis on your own and having to deal with all the administrative tasks of patching and failovers and all this sort of thing costs you more than just using ElastiCache. Something to think about. So one thing I like to do when I talk to customers is I like to make sure that they understand sort of some foundational aspects to AWS. The first one is where exactly your cluster lives, right? So the first thing I like to call out is you have availability zones. An availability zone is one or more data centers. Each one of these availability zones are independent. They're isolated from one another. They have various redundancies within themselves, and they live within a region. So a region is essentially a geographical location that consists of availability zones. Now, what you get when you have an account with AWS is you get something called a VPC. So a VPC is a virtual private cloud, which is kind of a slice of AWS. It's a logical network segmentation for your resources. Nobody has access to your VPC unless you provide that access. Now, within your availability zones, you create things called subnets, right? So a subnet essentially allows you to have network traffic to the resources that live within that logical segmentation. Now, for things like your databases and resources that obviously you don't want to have internet traffic to, you want to place those in a private subnet. That is where your Redis clusters essentially live, right? Now, prior to putting in your clusters, you also want to define something called a security group. So a security group is similar to a firewall, where you define protocols and ports that have access to the resources within that container. So your Redis cluster, obviously each one of those nodes is using your security group, and then it lives within this layered security. So if you know something about AWS, you know that our number one sort of concern is security, right? And so there's layered security here. Your resources are safe. The only way there's access to your resources is if you provide this access. Now, if you create a snapshot, what happens is that snapshot lives in a S3 bucket that we manage. You have access to export that snapshot, put it into your own bucket, and then once it's there, you can do all sorts of things like cross-region replication. You can archive that snapshot. You can do whatever you want. You can also take your snapshot. Say, for example, you are running Redis on your own. You can take that snapshot, and then you can use that snapshot to seed your ElastiCache cluster. Now, in terms of your public subnet or your resources that have external traffic, you would create a public subnet. You'd place your web apps or your servers that you want to have external access. You define other things, right? Like internet gateway, and you create the proper security rules that allows your security group in your public subnet to have access to your private security group, where your Redis cluster lives. Now, if you notice here, there's nothing in between your applications and your Redis cluster besides network security, right? So once you have that, you actually have direct access to your cluster. Now, why is that valuable? It's valuable because it provides you the lowest latency in terms of utilizing your Redis cluster, right? There's nothing in between. There's no proxy or anything else. And that's essentially what a lot of customers like, is they like that low latency that we provide you with ElastiCache, as well as, obviously, the security. Now, one thing that we do when we talk to our customers is we always talk to them about how do you architect your solutions with failure in mind, right? So if you plan with failure, if you expect that failure is going to happen, you will sort of build an architecture that will withstand failure, right? That's the goal. And so one of the core principles with doing that is essentially having your nodes in obviously a multi-AZ environment, and then making sure your applications also are built in a way that can withstand failure. Now, the other thing is, we ourselves, consider failure, when we build our services. So I'm going to talk about some failure scenarios. The first one is pretty obvious. Imagine you have a single primary that fails. So what we do is we'll detect that primary failed in a Redis cluster, and it will elect one of your replicas to be the new primary. Now, this takes within somewhere around 15 to 30 seconds the total time for the detection and the election. And then we'll also repair that failed node and make it a new replica. The other thing that we've done here is in the case where you have majority of primaries fail, and this is an enhancement that we built into our engine that's not supported with sort of the vanilla version, is we'll detect that you lost your majority of primaries, and we have controls around this, but we're still able to do election and restore the reliability of your cluster. And again, these are features that our customers have asked us about, and things that enterprise organizations really demand when you're using a managed service like ElastiCache. Now, we have a lot of customers using our product. This is just one slide of some of our public customers. But the takeaway really is that our customers really come from a variety of sort of verticals, right? Anything from media to with financials, all sorts of customers. And what we see with our customers is really interesting use cases that some of our customers are building, right? And that's everything from IoT to streaming data analytics. They use Redis for obviously caching, various types of caching, whether it's file caching, database caching, anything caching is Redis is used for. And then it's also used for things like filtering data, cleansing data, data decoration, and doing this in a real-time sort of process. And then there's the standard ones, right? The standard ones like leaderboards, gaming companies using leaderboards, PubSub for chat applications, things like that. So what I'm going to do is I'm going to talk about some of the common ones, and we'll also sort of dive into a few of the more interesting ones related to real-time data. Now, the first one in terms of caching is pretty straightforward, right? You use Redis to sort of cache the data before you hit your primary database. But what makes this interesting with AWS is that our database services, we allow you ways to proactively hydrate Redis, right? So take, for example, DynamoDB. Now, assume DynamoDB is your primary database. What you can do is every time you have essentially a CRUD operation on your table within Dynamo, you can have that data, utilizing a DynamoDB stream, propagate directly into Redis by triggering a Lambda function. So Lambda allows you to essentially be triggered off of a variety of event sources. DynamoDB streams is one of them. Now, what's cool about this is that logic that you would normally put into your application in terms of writing data to Redis can now sort of live in a different spot, right? And by living into that Lambda function, now you have flexibility by having a different development lifecycle, a deployment lifecycle, right? You can make modifications to that Lambda function without having to redeploy your applications. Now, obviously, your application still needs to know what if I get a cache miss. It's going to still need to read from the primary database, but at least a big portion of that logic is now abstracted from your main application. Now, the same thing is true with RDS. We have with Amazon Aurora. We have the ability to, anytime you write to a table, you can call a stored procedure, which has Lambda integration. So you can say, you can do things like anytime you write, maybe it's a customer table, you write customers to this table, you could propagate those customers into Redis, right? Now, another interesting pattern is this data enrichment. So data enrichment or data cleansing, filtering, this is a kind of a real-time need where you have data coming in through a stream or some sort of real-time ingestion engine, right? So in our case here, we're showing Amazon Kinesis Streams. This is our managed service for real-time data. And assume that you're collecting a lot of data from different data sources through this stream. Now, what some customers want to do is they want to look for interesting things in that stream. Or maybe they want to cleanse or decorate that stream. So what they'll do is they'll trigger a Lambda function anytime there's data in this stream. And because they want this to run in a near real-time operation, that Lambda function will pull records off that stream. It will query their Redis cluster, and it'll do things like they'll detect, okay, I see a customer record coming in the stream. Does this customer exist in my set? Or does this customer live in, do I have a hash that corresponds to this ID of this customer? And if it does, let me decorate or aggregate this information on this customer and then place that information in a cleanse stream, right? Maybe I want to summarize information. Or maybe if I see this particular customer coming through this stream, maybe I want to notify other applications. So this is where they might use the pub/sub feature of Redis and say, oh, I see something interesting coming in. Now let me publish this information. And it may be on the other side where you have the subscribers, you have another application that's waiting for particular records. And if it sees that information, it does something, right? So this is sort of one of the streaming type of use cases. Now obviously when you have the data in a cleanse stream, you could do other things with it, right? So we have Kinesis Analytics where you can run SQL on top of it. You can ingest this to another engine, just kicking off another Lambda function, various other things that you can do. But the core of this logic is really residing in utilizing Redis. As we're kind of talking about streaming data, we have a lot of other use cases where customers are sort of using big data architectures along with Redis. So I kind of talked about streaming data, but there's a variety of other services that can collect and ingest data, right? IoT being another one. Now, when you take this data, there's a variety of other engines and other projects and services that can collect that information. And then there's connectors from those, whether it's Spark on EMR or using Apache Kafka. There's a variety of other connectors that can push that information and then drop it into Redis, right? Now, by doing that, now you're using Redis sort of as a metadata store for all that kind of recent information, that transient information. But they also use Amazon S3 for their data lake, right? Now, once that data is in the storage spots, this is where additional analysis occurs. So whether you're using Presto on EMR or whether you're using Spark or kicking off another Lambda function, or maybe you have a custom application, you'll query your transient information, your active information that's residing in Redis. And maybe you'll also do analytics against your data lake. And then this is sort of where customers are sort of learning about that data that they just ingested, right? Now, while we're sort of talking about, learning about data and using Redis for, sort of transient information, another sort of interesting use case is using Redis as an event store. So I mentioned earlier that Lambda allows you to sort of trigger off of a variety of different events, right? So these are many of the different events that Lambda can be triggered off of. Now, once you are triggering off of these events, what some customers do is they want to have Redis act as an event store, so they know of all the interactions that have occurred from these other resources, right? So take for example, you want to use Redis to be aware of every code commit. You want to have Redis be aware of every CloudWatch log, or maybe specific types of logs. Maybe you want it to be aware of all your SNS notifications, and then you're doing some sort of dashboard on top of that, right? Or maybe you're publishing particular information to other consumers. This is a common use case. Another one that's pretty common is if you're building a RESTful API using Amazon API Gateway. And if you use Amazon API Gateway, it's pretty easy to build an endpoint. And then once you build that endpoint with your methods and your HTTP verbs, you can associate that to a Lambda integration. And then that Lambda integration can integrate into ElastiCache Redis. Now, why is that cool? It's very cool to do this for, obviously, caching or other types of interactions where your API is just using Redis behind the scenes. So this is something that we see pretty common. And then, in that same Lambda function, they might utilize another data store as well. So maybe they're using Redis, maybe they're using DynamoDB as well. So all that sort of business logic lives, again, in that Lambda function. IoT is something that's constantly growing, right? And we have a lot of organizations sort of building IoT devices and leveraging the AWS IoT platform. Now, one common pattern that we see for capturing sensor informations, whether it's temperature information for a particular temperature sensor, or maybe it's information about agriculture like moisture in the ground. The way this works is you install the AWS IoT SDK on the actual device, and then the information that's captured through that sensor is published to the AWS IoT service. And then once it's published there, you can kick off a rule, right? So the rule says, hey, I have this data. Now I want to place this data somewhere. And in this case, what we typically see is customers will either place that data in a service like Dynamo, or or kick off or maybe in a stream, or kick off an SNS notification. But they'll also use Redis to capture that time series data. And so it's very easy utilizing a sorted set, right? If your score is the actual timestamp, to capture that real-time information. And then maybe you'll use something like a hash map to capture the attributes associated to the sensor. So again, utilizing the Redis data structures natively to be able to query and build dashboards on top of this sensor information. With Redis 3.2's geospatial feature, we're seeing a lot of mobile applications utilizing Redis. So obviously, using Redis as a sort of a points of interest database. Imagine you have a mobile application, and your mobile application is passing longitude, latitude information back up to the cloud. Once you capture that longitude, latitude, do a georadius, and then recommend points of interest back to your end customer, right, your end user. And so this is becoming more and more of a popular use case. And in terms of adding those points of interest, there's a lot of options, whether you're doing it directly and writing directly to Redis, or again, utilizing some sort of automated trigger to hydrate your cluster. This is, again, something that we see pretty often. Dynamo with Redis seems to be a popular choice among some of our customers. Chat applications, kind of a common one. So what some customers use is they'll take advantage of Elastic Beanstalk. Elastic Beanstalk is a service that we provide that automatically deploys and manages your resources, including your applications. And then what they'll do is they'll kick off an application load balancer. Maybe they'll utilize WebSockets between their devices and the application load balancer, and then they'll have persistent connections going from their chat application back to Redis, right? And so this is a sort of an easy and quick way to build a chat application and just use Redis as sort of the communication server, that pub sub server, right? As your backend chat server. So with that, I just want to kind of summarize some of the things that we talked about today. Amazon ElastiCache, we provide you an enhanced version of Redis that we've added a lot of features, really around a lot of the feedback that we've gotten back from customers, things that give you a lot more reliability in terms of edge cases with failovers and dealing with snapshots, things like that. The other thing is if you evaluate your actual TCO, it's very cost effective to utilize Amazon ElastiCache in addition to removing all the administrative headaches for managing your cluster. A big benefit is the native integration that you get with other AWS resources. So this makes it very easy to stitch your applications together and kind of build an application utilizing AWS. You get obviously the support from AWS. And it's fully managed, right? So there's nothing that you essentially have to worry about besides putting your data into ElastiCache and deciding on what size you want that cluster, along with whatever parameters you want to tune how that cluster behaves. And that's it, right? So it kind of gives you back the power to just focus on your business and not have to worry about this other stuff, right? And that is essentially the heart of what we offer you. Thank you guys for your time. Appreciate it. Thank you. So I think we have a couple minutes. If anybody has any questions, be happy to take a couple questions. And then for whoever we don't get a chance to answer any questions, please stop by our booth. We're going to have Kevin, we're going to have a few of our product team there to be more than happy to answer your questions.
So simple naive question, is the only backing store for ElastiCache in S3? Or do you have any other ways to?
So it's a good question. So in terms of your RDB files, we do capture that in S3. And S3 has 11 nines of durability. So that is your backing store. And then once you have that RDB file, there's various things that you can do in terms of having your data in S3. Yep. Anything you want to add to that, Kevin? Yep.
It's relatively slow.
What's slow?
It's relatively slow to save a billion keys with an RDB.
So your data is in memory, right? But if you were to do a snapshot, that snapshot is actually stored in S3. It's the actual output of your snapshot that's in S3. The data is in memory. So you're not dealing with the data directly in S3 unless you want to seed your cluster or do something with the cluster. Does that make sense?
What's your recommended pattern for multi-region deployment?
Good question. It really depends on your goal, right? And it also depends if you have any other backend database. So usually I like to take that question in terms of a specific architecture. But if it's a caching use case, what you want to ask yourself is, how hot do you want that data, right? If you want that data to be extremely hot you said multi-region. If you want that data to be hot in the other region, you can create a network connection between regions. There's nothing forbidding you for doing that. So if you create a network connection, your workload can write to both regions. That's an extremely hot use case. So you can do that if you wanted to. What some other customers do is rather than having a hot, they may take snapshots in one region and then do cross-region replication with that snapshot. And then as soon as that snapshot finds itself in the destination region, they'll trigger a Lambda function, which will seed and update the destination region. Because in that particular use case, maybe their RPO doesn't require that hot. Maybe they just want it to be there in case of a DR reason. And there's other possibilities too, right? You can also just rely on your backend database and then just seed your data through your database. It all really depends on your actual your needs. But that would be kind of a general recommendation there. Yep. So what's the SLA involved with the fluctuation between 15 and 30 seconds? So there's essentially time associated to detecting a failure, right? And we don't want to be too aggressive in terms of identifying whether a node failed, because there could be like a network hiccup or some other anomaly that might be triggering that off. So we delay this for the detection roughly about 15 seconds. And then anything after that is essentially just the failover process. So we typically say 15 to 30 seconds just to be conservative, but I don't have an actual SLA, but it's usually within that window that we typically see. Yep. All right, guys, thanks again. And please stop by our booth. We'll be more than happy to spend more time with you guys. Thank you.